Well, welcome back, guys. This is our last night of related rates. I don't know whether that makes you happy or sad. But anyways, I think we've got a pretty nice way to end the section on related rates. So please don't feel like you have to be an expert at this point. We do have the rest of the year to practice this topic. And good luck tonight. Question 1. The radius of a circle is decreasing. Okay, so hopefully you caught that that's negative, at a constant rate of 0.7 centimeters per second. So hopefully we're pulling out dr dt equals negative 0.7. In terms of circumference C, okay, so basically what they're saying is they want to see a C in your answer, which represents circumference. What is the rate of change of area of a circle? So I am finding d a dt. All right, so hopefully pretty straightforward. I need two formulas. First of all, they're asking for area and they're talking about circumference. So let's recall area equals pi r squared and circumference is equal to 2 pi r. Now, of course, it's also equal to pi d, but 2 pi r is used most often. So they want me to find the derivative of area. So let's go ahead and do so. Basically taking, again, this derivative with respect to time. So I get d a dt equals, this derivative is just 2 pi r d r dt. And just be careful, it says it wants it in terms of circumference C. So basically, you should see circumference in your answer. And that's why it's important to write it down. Do you see 2 pi r in your answer? Well, sure. So d a dt is equal to C times dr dt, which is negative 0.7. So I would say d a dt equals negative 0.7 C. And my units, of course, if I scroll back, were in centimeters per second. And that's simple. So we're just talking about related rates in terms of another function. Question 2. The side of a square is increasing at a rate of 2 inches per second. So they're giving me the derivative of a side of a square. So basically, I'm going to picture a square. Of course, all the sides are the same. And I'm going to call this side S. So they are giving me d s dt. Since they said increasing, we should know it's a positive 2 inches per second. In terms of perimeter P, so basically they want to see a P in the answer for perimeter. What is the rate of change of area? So the question is, what is d a dt? All right, so hopefully pretty straightforward again. They want to know about area, so clearly take its derivative, but they also want to include perimeter. So let's just think about it. What is the perimeter of a square? Well, perimeter is just add all the sides together, and if it's a square, they're all equal. I would say the perimeter is 4s. And how about the area of a square? Well, again, because it's a square, it's just length times width, so I'm going to say s squared. All right, so once you know your two formulas, and they should be pretty straightforward, let's take the derivative of area since that's what the question was about. So I get d a dt equals the derivative of s squared is just 2s d s dt. All right, now I don't see perimeter at the moment because perimeter is 4s and I only actually have a 2s. But what do we know about ds dt? Well, ds dt was 2 inches. So I can replace that with 2 and I actually get d a dt is equal to 4s. And now I can say, well, 4s is actually p. So d a dt is equal to p. And that's what they were looking for, to express my answer, my rate of change of area, in terms of p. Next example. A ripple on a pond surface expands such that its circumference increases at a rate of 25 feet per second. All right, and again, those units should give it away. They said the word circumference. I'm saying that's the derivative of circumference, the rate at which it's increasing. So I'm positive 25 feet per second. All right, so I'm just identifying all these variables. How fast, so I'm looking for a rate, is the area. So I'm looking for d a dt increasing when their circumference of the circle is 49 pi. All right, so I've got everything I need. Of course, they told me I'm a ripple on a pond, so hopefully you recognize that as a circle. And they do say it down there, circle as well. So the first thing I said to myself was, well, clearly, if I know dc dt, I should probably take the derivative of circumference. So I'm going to start with the circumference of a circle is 2 pi r dc dt equals 2 pi dr dt. I know dc dt is 25, 2 pi dr dt. So basically, what this solves is what dr dt equals. 25 over 2 pi equals dr dt. Now, clearly that doesn't answer the question, but that's going to be a key cog in finishing out what I need. So I'm just going to check off that I've used that fact. They want the derivative of area, so now I'll probably go to that next and take the derivative of area. Area equals pi r squared. So its derivative is dA dt equals 2 pi r. And then, of course, dr dt. So that was the question. What is dA dt? I've got 2 pi, hold up, don't know what the radius is. All right, so I'm not done, but I do know now that dr dt is 25 over 2 pi. All right, so then I just say to myself, well, what haven't I used? I can check that off, check that off. I haven't used the fact that circumference equals 49 pi. So now off to the side, let's just say circumference equals 49 pi. And of course, circumference is 2 pi r equals 49 pi. I can easily kill a pi on each side. So my radius is 49 over 2. So now I can use that fact and substitute it in here. All right, so now I'm just going to go through and ask myself what cancels and what doesn't. So basically this pi on top, you can put that over 1 if that makes you feel better. We'll cancel with that pi on the bottom. This 2 on top will cancel with that 2 on the bottom. And I basically get dA dt equals, I'm going to leave it for the time being, whatever 49 times 25 is, divided by 2. And my units, because I'm talking area, don't forget there's going to be something squared. So I'm going to go back and say that was feet squared per second. And there you have it. So just make sure you use all pieces before you get your final answer. Next example. The surface area of a cube is increasing at a rate of 36 centimeters per second. So I'm going to use dSA for the derivative of surface area. Increasing is a positive 36 centimeters per second. So I'm listing out what I know. How fast, so what is the derivative of volume? dV dt. That's what we're looking for. Changing the instant the plain old surface area equals 300 square centimeters. All right, so let's get the formulas we need. Clearly, we need surface area and we need volume. All right, now picture a cube. All right, basically the surface area is just the area of every surface. So if I take the front surface, all right, I'm just going to say it's side by side. And a cube obviously means that all the sides are equal. So the area of that is s squared. Now, how many of those do you have? Well, 4 around and 2 on the top and bottom make a total of 6s squared for surface area. The volume, because it's a rectangular prism or cube, is length times width times height, but be smart, since it's a cube, they're all the same. So I'm just going to say that side cubed. All right, so I'm just going to check them off one by one. I see the derivative of surface area, so that's what I'm going to start with. Surface area equals 6s squared. Take its derivative, so dSA dt equals 12s d s dt. And I'll just plug in everything I can. This is 36, 12. Darn it, I don't know what the side is, and I don't know what ds dt is. I've got 2 blanks. All right, so I can't finish that, but what I can do is go figure out something based off this one. All right, so let's say 300 equals 6s squared. They're telling me the surface area is 300. So if I divide both by 6, I get 50 equals s squared. Take its square root, and you could simplify this, but I think it's just nicer to leave as radical 50 as my side. So now I know what s is, and I can substitute that in here. So I'm going to put my radical 50 in there. Now I have what I'm looking for is ds dt. So I'm going to say that's 36 divided by 12 radical 50. equals ds dt. All right, so I can simplify that actually. Whoops, 12 times 3 is 36, so I'm going to say that's 3 over radical 50 equals ds dt. Now again, you don't need to rationalize, so don't waste your time doing that. So now I've officially used that piece and that piece. Now the question said, what is dv dt? So let's go get dv dt. So we said volume equals s cubed. dv dt equals 3s squared ds dt. So I'm looking for dv dt. I've got my 3. My side turned out to be radical 50. And now it's side squared, so radical 50 squared. And ds dt was 3 over radical 50. So as I clean this up, notice how nice that is. The square and the square root cancel. So I'm going to put that over 1 and that over 1. So I have 3 times 3, which is 9, times 50 is 450, all over radical 50. And again, you don't have to rationalize anything. I would just watch my units, and we were finding volume. So of course I'm going to say that that is centimeters cubed per second. Next example, a spherical shaped balloon is being filled at a rate of 100 cubic inches per minute. So again, let's stop there. Spherical, so not circle this time, we're talking about the sphere. Do you remember that volume formula? Volume equals 4/3 pi r cubed. And they're talking about the rate that it's being filled, so I know dv dt is being filled, so that's a positive 100 inches cubed per minute. At what rate is the surface area? So what is the derivative of surface area? Of the balloon increasing when the diameter equals 24. All right, so not only did we need volume, but we needed surface area as well. Now we said there's a quick way to remember the surface area formula. You just simply take that volume's derivative. Well, when you do that, those 3's cancel and you get 4 pi r squared. So make sure you have those two formulas memorized, of course. All right, so I'm just going to go through step by step and use what I can. The first thing I know is dv dt, so I'm going to take the derivative of volume. So if volume equals 4/3 pi r cubed, dv dt equals 4 pi r squared dr dt. And again, I'm going to figure out everything I can. I know dv dt is 100, 4 pi. Now, do I know the radius? We'll use some common sense. We know the diameter, therefore we must know the radius. That's going to get me a 12 squared dr dt. So look, I can easily solve this for dr dt. Now, even though that didn't answer the question, I'm going to need it later on. So I've got 4 times pi times 144 dr dt. So that gets me 100 equals 144 times 4, 576 pi dr dt. So I'm going to say that's 100 over 576 pi equals dr dt. Now again, that didn't answer my question. That just provided a piece to the cog that we're going to need. All right, now the real question said, what is the derivative of surface area? So let's go find that. Surface area was the derivative of volume, so that's 4 pi r squared. Now I need its derivative, so dsa dt equals 8 pi r dr dt. I'm looking for that rate of change of surface area. I've got 8 pi. We said we knew the diameter was 12, or the diameter was 24, so the radius is 12. And use this dr dt that you had here. 100 over 576 pi. Now, we can clean that up a little bit. Clearly the pi on top is going to cancel with the pi on the bottom. Let's see, 12 goes into 576 48 times. 8 goes into 48 6 times. So I've got 100 over 6, or I could divide those both in half and get 50 over 3. And my units, of course, because this is surface area, I better say squared. I'm going to say inches squared per minute. That leaves us with the last problem of the night, which we will look for in your notebook as a quiz grade. So take your time, write everything out, and hopefully you're feeling pretty comfortable. We'll see you tomorrow.